These are problems for some of the greatest minds on Earth, so let's see if you can tackle them. At the beginning of our universe, 13.7 billion years ago, the Big Bang occurred, creating the existence of absolutely everything from a single point and expanding it outwards at the speed of light. When this massive reaction event occurred, it should have disappeared right away. According to the models that explain our understanding of the laws of physics, the Big Bang should have created an equal amount of matter and its opposing twin antimatter, and the two should have canceled each other out and basically ceased to exist. But for some unknown reason, an imbalance between the two occurred that has allowed us to be around and do things like watch cat videos on the matter side of things, while antimatter, like black holes, sit in areas few and far between our matter-filled universe. One theory states that there is no imbalance and that the created antimatter that would destroy everything lies in several gigantic sections outside of our observable range. Well, let's hope that we never see that. Protons are a positively charged subatomic particle and are one of the most basic building blocks of mass and life itself. But is their charge constant, or will they lose their power and become neutral over time? The theory of proton decay suggests that these particles may be slowly changing through radioactive decay, releasing its charge until it becomes a neutron. This decay has not been observed, but it may be because the proton's lifespan is so great that the decay cannot be observed over our lifetime. It's possible that their charge lasts millions of years before it emits enough radiation to become unstable. But thankfully, no evidence to support this has ever been discovered, and if they aren't decaying, they must somehow remain charged indefinitely, which is extremely impressive. The answer isn't clear, but if these protons that make up everything eventually fizzle out, it could literally be the end of us and everything. In our conventional understanding of physical states of matter, atoms made up of subatomic particles make up molecules which give us elements like H2O. These elements can transition into various states of matter, like solids, liquids, and gases, through very high and very low temperatures. Now, most of this is common sense science class stuff, right? But what if we took that process and cranked up those temperatures from 10 to somewhere around 10,000? Would that start to alter the atomic building blocks for the molecules? Perhaps if the restrictions around temperatures that we can manually achieve were lifted, some much more unique states of matter could be created. Through this, we could change atoms at the subatomic level and cause the creation of new atoms, energies, and even forces to appear. But for now, physicists have to remedy this issue of our current temperature limits and find a way to get atoms hotter without basically burning a hole through Earth. Now please don't do that, I don't want to die. It's worth the scientific exploration, but not at the cost of my life, thank you. Parallel universes sure are a fun topic in science fiction stories, but their existence may be completely possible depending on the shape of something called space-time. Mathematical models in physics that combine both the values for time and space create a measurement for space-time, and things get real complicated when you try to deduce its shape and how that affects our perception of reality. In one popular theory, space-time is completely flat and extends infinitely, but since there is only a limited number of possible variations of our existence, it means that everything that exists occurs indefinitely forever. By that logic, we all exist again and again in other universes, just like ours, sometimes in exactly the same form and sometimes in a drastically different form. If that doesn't explode your parallel minds, try adding intangible extra dimensions into the equation which allow universes to exist in stacked layers within ours. My brain hurts. The arrow of time is an idea that was created in 1927 by Arthur Eddington, a British astronomer, that describes the one-way nature of time and how a theoretical element called entropy governs it. Time as we know it is always moving forward, and everything that moves with it increases its entropy, a value that cannot be reversed. Entropy itself is described as the amount of disorder in a system. For example, gas locked inside a canister has particles that float around and cause imbalances in its distribution. All this increases its disorder and therefore its entropy. However, if the gas somehow remained and maintained itself in the same evenly spread position forever, it would stop the value of entropy from increasing. If we think about measuring time through how much all our stuff gets messed up and disorganized, the entire universe must have been neatly ordered inside a tiny little package before the Big Bang. And the question is, how the heck does that work? I'm gonna need some Advil after this video. Sonoluminescence is a strange occurrence in physics that involves using sound waves to create air bubbles in water. As the bubbles pop in the water, they create a minuscule flash of light that only lasts for a few hundred picoseconds or less, which happened to be just long enough for scientists back in 1934 to take notice of it and then launch studies on it over the next 8 decades. That's a whole lot of time for studying, baby. This light-generating bubble magic only occurs when the force of sound waves are used to create them, and physicists still have no real explanation for where the light comes from. Some theoretical explanations say that when the bubbles collapse, they quickly compress any gases trapped inside and end up creating astoundingly hot temperatures and producing a small amount of plasma that glows. Others chalk it up to electrical reactions and mini nuclear fusions that give off light, but studies have struggled to collect any real supporting evidence. One of the long-standing question marks plaguing physics involves one of the more common materials in modern products, glass. To be more specific, physicists cannot understand how glass forms and why it remains solid. Let me explain. In its superheated molten form, glass is liquid, and the particles that make it behave like liquid. But as the glass cools into a solid form, the particles in some areas can continue to behave as if they're liquid. In solid form, glass's molecular structure does not resemble that of any other liquid to solid transition, which forms a neat and organized order in solidity, as opposed to glass, which simply looks like a liquid that stopped moving. This molecular behavior isn't limited to glass either. Some plastics and ceramics also fit the description too. Who knew that something so widespread and skillfully created with origins dating back to 3500 BCE would be so mind-boggling to the modern-day scientific community? In space, lots of crazy things are happening at the quantum level, with particles appearing in and out of existence and generating a large amount of energy at an almost infinite rate. When physicists calculate this energy, it comes out to be an amount so huge that the vacuum force would cause the entire universe to curve so sharply that nothing would exist past the moon. However, the problem is that if Einstein's theory of gravity is right, it means that there is only really a small amount. This calculation is called the cosmological constant problem, or the vacuum catastrophe, and has been referred to as the most striking problem in contemporary fundamental physics. Nobody can find the missing piece to reconcile this, and the issue persists as a quantum physics model that should theoretically work, but folds the universe into itself instead. Dark energy is one of the most powerful yet elusive forces of all time, if it even exists. In 1998, astrophysicists discovered that the expansion of our universe was getting faster and faster rather than slower. Pondering how this could be possible, they determined that a strong force must be working against gravity to cause it. So they named this invisible force dark energy, and it has become the most logical explanation for the phenomenon. Dark energy accounts for an astounding 68.3% of space, ahead of dark matter at just 26.8% and tangible normal matter at a measly 4.9%, which is completely mind-blowing. Since not much is known about dark energy, there are a number of different things it could be, from chameleon particles to gravity itself, which science still does not fully understand. Whatever dark energy is, it's everywhere, and understanding it could provide deeper insight into the past and future of our universe. If the human race ever manages to survive billions of years into the future, we'll still be doomed because of two theories called the Big Crunch and the Big Rip. Through our observable universe, we can surmise that the Big Bang caused everything to fly away in different directions, and we can also tell that the rate of this separation is accelerating. The Big Crunch happens when this expansion of the universe stops and then starts to contract again like the biggest rubber band snap ever. But if we don't get reverse Big Banged, we could run into problems when the rate of expansion gets so fast that matter just can't handle it anymore. If the current rate of acceleration builds over billions of years, it could tear matter apart at its most fundamental levels, causing the Big Rip. It's completely unknown if either will actually happen, but either way, humans won't survive it unless we can find the universe's emergency escape door. Crunch. Well, other than us being doomed, I just want to remind you that my limited edition t-shirt is only available for 2 weeks until June 5th, and once they're gone forever. So, get it now before it sells out by clicking the little eye on your screen or the link under this video. And don't forget, I'll have a brand new video for you tomorrow at 3 Eastern Standard Time. I'll see you then.